individual actually coined that phrase was Craig Mount when he was with the CRD, and he said, "Look, we should be talking to people in terms of we're trying to achieve a light hydrologic footprint." And I guess he probably read Bill Reese's stuff about the ecological footprint right at that point. And I think now it's becoming more meaningful to people. So, okay, if you had gone on site last night, if you got your note in time, but after today when you go back to the office, if you go to waterbalance.ca, this is what you see. That's your first screenshot. And so, I just want to quickly walk us through it so you'll know what you experience when you do it. So when you go there, you'll see the map of Canada. Click on BC. Now the other thing I want to bring to your attention here is the 3 scales of application, sites, developments, and watersheds. That's the capability we have now. Right? Whereas before we were really, the old water balance model, we were really, we could do on a watershed basis, we could do broad brush land use planning. We could say if we change the land use, but in terms of, from an engineering perspective, we were limited to a site condition, whereas now we have that capability to look at things from an engineering point of view and actually simulate what's happening in the creek. And so that's your first shot. Once you've clicked on that, you'll go to this page, which is the British Columbia page. And I would urge you to read the explanatory articles. This is really a big part of your user's guide. So that when you click on here, it says about the model, how to use the model, and what you'll get there is your basic explanations of the tools. So that's the first 2 impressions. A series of slides which were created by Richard Bowes of the District of North Vancouver, and he found that this series of 3 or 4 slides here had a very profound impact on his council, because he was able to, and this pick up on your point, visually show what's happening. So what he did here was he picked a piece of property which was with a house built 50 years ago, and using the GIS system, he came up with these percentages. And so it doesn't matter where you go. If you look at older properties, right, it's always small house, big lot, because the houses were small. And so here's your basic statistics. The footprint is only 13%. You've got half the property is tree covered. You've got 90% hard surface, and you've got over here 15% landscaping. But it's giving you the basic numbers of a piece of property. And then he went to a newer piece of property, and everything's changing, right? The building footprint is up to a quarter of the lot from the 13% before. Look at the hard surface is increasing. And he said, he happened to take a piece of property which actually had a tree covenant. Funny somebody mentioned RER, but so at least a bit of this property is protected by a tree canopy. But what he was trying to show here was what's happening, and this is happening everywhere. So we took.
Kim, can we just go back to that? Is that
so? These are the numbers that Richard Bowes generated using this example. Because what he wanted to show was, always look at the red. That's the runoff, right? So the runoff from the.
So Kim, maybe just to go back, if folks haven't had a chance.
See the output. This is why it's important that you convert the. We have a simplified approach. If this was pure engineering, you'd have
a 2x4.
Yeah, as opposed to that much. I mean, that's why the biggest bang for the buck really is soil depth, and that's what Surrey concluded after they did the monitoring on the East Clayton development, was that the biggest bang for the bucks they were getting was on soil depth. And so as a result of that, they're being more stiffer in their enforcement. Bridget?
Where do some of the inputs come from, like the rain, the rain pattern and so on? If somebody's, most offer, sitting at their computer plugging stuff in, where are they gonna get that information? Is that on the website?
Yeah. We have, next slide will show us there. Coming up next. Yes, we have a number of climate stations upload their Environment Canada climate stations. Before I get that, again, what Rich was showing this council was on this 50-year horizon, in terms of the number of days where you have the stream erosion. That's what everybody forgets is because you change the land surface and you have more runoff, you have more days where you're causing erosion. Because a creek is always trying to find equilibrium, and it can't find equilibrium if the landscape is constantly changing. And so the threshold at which the erosion occurs happens at a lower level, and you have more of those days. And what this was showing was that for the McKay Creek watershed, which was a fully built-out watershed, but it was subject to further impacts because of climate change and redevelopment. And so what this was showing, the climate change, it was going to get worse over time. So go from 80+ days per year where you're beyond that critical erosion velocity to about 90. What we then looked at was, what if we tried different things on a watershed basis? What if we were able to wave a wand over 50 years and change our development standards? What could we achieve at the end of 50 years? And we were able to show through the combination of just infiltration, and all that would come through just changing your soil depth requirements on an individual family lot, plus requiring infiltration trenches. How you could knock it down from that 80+ down to the order of 25. So that's the kind of graphical presentation starts to change how people make decisions.
Kim, it's kind of important too to acknowledge duration and
Right.
just have it quality.
And that's well said. That's kind of a nice segue, because now why have we gone the next step with the new water balance model? Because it is not just about the site; it's about finding optimum. Because you could implement every possible best practice, and you could just dry up your watershed, so that there's no water for the fish. And that's really what came out of the Fergus Creek plant. To see a sort of pilot where we're at now, which is that if you did everything, you'd go too far. So it's kind of like